I'm sorry, we're getting there. We're getting there. There's one last thing we need to add in, and then we'll have everything you need for test 2 coming up. So check this out. Here we go. Back to our list. The last thing we need to add to the list is mass. The amount of material in that star. Is that our final direct one or our final indirect one? Is mass the amount of material in that star, direct or indirect? Indirect. Here we go. Indirect. Here we go. Let's pop it in there. It's indirect. We can't see inside the star, so we can't know it directly. Here we go. So how do we figure it out? How do we indirectly find the mass of a star? We find it indirectly. Okay? We find it indirectly. What would the way to indirectly find it? What does mass cause? If a star has more mass, that means it's also going to have more what? What does increased mass give a star? More gravity. Correct. So by watching how nearby objects are affected by the gravity of a star, we can figure out what its mass is. Okay? And what we've learned is that for almost all stars, all of the other properties other than distance are tied to the mass. Okay? All of the other properties for most stars is tied to the mass. So here's what we can do to make everything easier and bring it all together. Here we go. I'm just going to turn this over here. Check this out. Let's say we're looking at a star like our sun, and we increased the mass. All right? Let's bring it on home. If we increase the mass of a star, what probably happens to the size? What probably happens to the size? It gets bigger, okay? More mass means a bigger star, okay? And as you guys said, more mass means more gravity. So that means a star with a higher mass will squeeze itself more tightly. Not enough to shrink the star, it's still going to be bigger. But if it's squeezed more tightly, what does that do to the temperature? If this star squeezes its core more tightly, what's that going to do to the temperature of that core? Would it go up or down? It would get higher. That's something we talked about way back when we were talking about meteorites, right? So what does that mean? That means that if a star has a bigger mass, for most stars, that's going to mean it's also going to have a higher surface temperature. So increasing the mass of a star, looking at bigger masses means bigger sizes and bigger temperatures. What is that going to do? Check this out. If the core and the surface are hotter, that's going to affect the fusion inside. Would making it hotter make fusion happen more or less often? Would higher temperatures inside the star make the fusion happen more or less? More. It would happen more, okay? More. It would happen more. So here we go. That means if the star fuses more, its luminosity is going to go up. Okay? Now, here's the thing. This means for most stars, the higher the mass is, the higher all of the major properties are. Okay? The higher the mass is, the higher all of the major properties are. Now, I said most stars. That's because there are some stars that don't follow this pattern, okay? This is for stars like our sun, which we actually call, here we go, main sequence stars. This is just the name that we give to stars like our sun. In other words, stars that haven't started to die yet. Stars that are still fusing hydrogen in their cores. So for most stars, it's like this. Let me just bring it all together in the final part. Here we go. Let me bring my spectral types back in. Now remember, for main sequence stars, which is almost all of the stars out there, almost all the living stars, all of the properties increase together. Okay, so here we go. We said for these spectral types, let me pop myself under here. For these spectral types, O's are hot, M's are cold, stars that are G's, like our sun, are kind of medium. But if we're talking about main sequence stars like our sun, let's see if we can figure this out. Which of these two types has a higher mass? B or G? Which of them has a higher mass for main sequence stars like our sun? And keep in mind, when you're answering this, remember, all of the properties increase together for main sequence stars. It's the B's. It's the B's, right? So, if B's are hotter than G's, then for main sequence stars, that means they are bigger than G's as well, okay? What is, what's a bigger mass, F or K? What's a bigger mass? F. So let me put some extra notes on here, and this will help you out for anybody who's not quite getting it. So for all stars, hot is the O side and cold is the M side. But for main sequence stars, like our sun, we also get this side being high mass, big size, and high luminosity. Because all of the properties go together, right? So for main sequence stars, this is not just hot, it's also high mass, big size, high luminosity. Whereas on this side, for the cold side, for main sequence, these are also going to be low mass, small size, and low luminosity. Okay? So basically, there's going to be a bunch of test questions like this on test number 2. I will just have a list of letters. They won't be in order. You need to know the order, okay? But I'll say something like, okay, you've got an A, an F, and a K. And it could be more than that, but let's say we had an A, an F, and a K, and I could ask, okay, which one of those is the biggest size? And what would the answer be? For A, F, and K, what would be the biggest size for main sequence? A, because it's closer to that list, right? Which one would have the lowest luminosity? K, because it's closest to that list, right? So the closer you are to this side, the more like this you are, right? And the closer you are to that side of the list, the more like that list you are, okay? Let's put the final type of question. Here we go. Last bit of info. These things, there's billions of all of them out there, but they're not all just as common. Which side would you expect to be more common? M stars, the small cold ones, the small dim cold ones, or the big hot bright ones like the O's? Which one would we expect to be more common? Yes, so M's would be more common. There's way more little boring ones than big, hot, bright ones. These would be easier to see, but there's way less of them. Does that make sense? So it's just, here's a way to remember that. It's just like people. What is more common out there in the world? Boring and small or hot and bright? Just saying. It's just like people. The cold, small, boring ones are way more common than the hot, bright ones, right? So the stars are like that. It's just the way it is. We can't all be O's. Most of us are M's. Aw, okay? You decide which one you are, all right? Yeah. So that's it. That's the whole that's everything that we're going to be doing for this semester. Somebody's asking about dark matter. I will have a lecture on dark matter over the summer. So stay tuned. I can teach you all about dark matter if you pay attention to that.